Hello students, let us see one more problem that involves the small smooth pulley and light inextensible string. So let us just read this question carefully. Two particles A and B of masses 3 kg and 5 kg respectively are connected by a light inextensible string. Particle A lies on a rough horizontal table at a distance of 3.5 meter from a small smooth pulley, which is fixed at the edge of the table. The string passes over the pulley and B hangs freely with the string taut 1 meter above the horizontal ground. The frictional force of magnitude 0.8 g Newton opposes the motion of the particle A. The system is released from the rest. So here, just keep this word in mind. The string is taut means there is a tension in the string, and when I say string becomes slack, that means the tension becomes zero. So let us draw a diagram. I'll put the diagram for this situation here. So this is the diagram that shows the situation here. Now here particle A is of mass 3 kg and it is kept on the rough horizontal surface. This is a small smooth pulley. This is the particle B of mass 5 kg. And let us show the forces acting on this system. First of all, because the string is light, how does that modeling help? There is a uniform tension. So the tension from the particle to the pulley and from pulley to particle by Newton's third law. Then the weight of this particle acting downwards 5g, and the frictional force acting on this particle because it is on the rough surface 0.8 g. Keep it in mind that here, because the particle is moving horizontally and the friction is given directly to us, we will not consider the weight of this particle. Then secondly, the string is inextensible. That means both the particles will accelerate at the same rate. So this is the diagram for this particular situation. So let us write the equations for particle B. For particle B, the resultant force is downward. So pi g minus T is the resultant force. Force down minus force acting upwards on the particle, and that is equal to by Newton's second law pi a. Similarly, for particle A, the particle A is accelerating towards right. That means the resultant force will be force on the right minus force in the opposite direction, that is the friction 0.8 g, and that is equal to 3a. Now just add these two equations, because when you add, t will get cancelled, minus t and plus t will get cancelled, so you will get 5g minus 0.8 g is equal to 5 plus 3a, 8a, and that is 4.2 g is equal to 8a. So a is equal to 4.2 g divided by 8, and that is equal to 5.15 meter per second square. And since the string is inextensible, both the particles will accelerate at the same rate, 5.15 meter per second square. Now the next thing that is asked to you is the time taken by B to reach the ground Now the particle B is kept 1 meter above the ground. That means the displacement of this particle S is 1 meter, acceleration is 5.15 meter per second square, and the particles are released from rest, so u is equal to 0. So using S is equal to ut plus half at square, we get S is equal to 1. Now ut will be 0 because initial velocity u is 0, so half into 5.15 into t square. So t square is equal to 2 upon 5.15, which comes out to be 0.388. So t will be square root of 0.388, that is 0.62 seconds. So particle B will take a time of 0.62 seconds to reach the ground. Now I will draw the diagram again to explain the next part. So now since the string is light and inextensible, when this particle will travel 1 meter down, and both the particles are accelerating at the same rate of 5.15 meter per second square, and both the particles are released from rest. And that will mean both the particles will have the same displacement. So when this particle will go down by, particle B will go down by 1 meter, particle A will come forward by 1 meter, and say it will come to a point X here. So this is the point X here, which is 1 meter away from the starting point. Secondly, now this particle is reaching the ground and it will touch the ground with a particular velocity. So with whatever velocity it will touch the ground, with the same velocity particle A will come to point X. So let us first find the final velocity of particle B. So V is equal to u plus at. Again u is 0, A is 5.15 and T is 0.62, which will give 3.19 meter per second. So this particle will touch the ground with a velocity of 3.19 meter per second, and since the acceleration of both the particles is same, the particle A will come to point X with a velocity of 3.19 meter per second. Now, when the particle A comes to point X, particle B has touched the ground, so the string will become slack. So, as I already told you, the string is slack means there is no tension. So, tension is 0 Newton. The other force, the resistive force acting on this particle is 0.8 G. And particle will be still accelerating forward, but now the acceleration will change because the resultant force on the particle has changed. So it will travel some distance forward and it will stop at a point, say y here. So at y, its velocity will be 0. It will stop completely. So between x and y, the particle will decelerate. So at x, what will be the resultant force? 0 in the forward direction minus 0.8 g in the backward direction. Keep it in mind that even the forward force has become 0. The resultant force is still in the forward direction because the particle is still traveling some distance forward from x to y. So this is equal to 3a by Newton's second law. So a will be negative 0.8 g divided by 3, and that is negative 2.61 meter per second square, taking g as 9.8. So that means after x, the particle will decelerate due to the friction and it will travel from x to y. So for the journey from x to y, now as already told to you, the initial velocity at x will be 3.19 meter per second with whatever velocity particle B is touching the ground. With same velocity particle A will come to point X. So it is the initial velocity for the journey from X to Y. At Y, the particle will stop. So V is equal to 0. And now the acceleration of the particle will be negative 2.61, which means it will decelerate due to the friction. So A is negative 2.61 meter per second square. Using V square is equal to U square plus 2AS. So V square will be 0 square. U square will be 3.19 the whole square minus 2 into 2.61 into S. So S will be 3.19 the whole square upon 2 into 2.61, which is 1.94 meter. So the total distance traveled by particle A, total distance traveled by particle A will be first 1 meter and then 1.94. So total 2.94 meter. So first when the particle B comes down by 1 meter, particle A will go from the initial point to x 1 meter and then it will travel the remaining 1.94 meter due to the friction, the deceleration due to the friction. So total it has traveled 2.94 meter and it has kept at a distance of 3.5 meter from the pulley. So it does not hit the pulley. So this particular concept I'll just repeat once because the string is light and inextensible. Inextensible means the acceleration of both the particles is the same and both the particles are released from rest. So that means the initial velocity is 0 and because the string is inextensible, both the particles will accelerate at the same rate. So when particle B is traveling 1 meter down, particle A will go 1 meter ahead towards right, then the string is becoming slack. So whatever velocity of the particle B when it is touching the ground with same velocity, particle A will come to point X and then it will decelerate due to the friction because the string is becoming slack. That means forward force will become 0. So it will travel an extra distance xy and then it will stop. So wish this concept is clear with you. So I'm just giving you one more question to try yourself on a very similar lines. And this question I'll be discussing with you in the next class. So if any doubts are there, please ask me in the next class. Enjoy the day ahead, students. See you in the next class.